Thursday's class continued, part 2, and let's look at what the rest of our discussion for today is light as a wave. So we've talked about light as a wave, and we've talked about it being transverse and so forth, but the question about a wave is what is producing the wave. So there's always a medium. There's a substance that's actually oscillating. So we've discussed that already. So if you would tell me, if I throw a rock into the water, the waves, here's the rock, and the waves went out from it. Remember these circles, these are representing the crests. So we have clumping, clumping, clumping. In these waves we have crest, crest, crest. So if it was a sound wave, you'd see that. Water is a transverse wave, so we would see this. So if we're looking at this kind of action, we can see clearly that the waves made by this rock are propagating through the substance of water. So the medium is water. So rock in the pond, the medium is water. So that's not so hard to understand. When I yell at you and you hear me yell, "Stop it!" Can I yell at you again? All right, here goes. Shannon, hold on to your socks. Stop it! All right, how was that? All right, my neighbor's all running over now. All right, so when I yelled at you and the clumpings came like that, what was the substance that was being oscillated? Air molecules. All right, you can probably see I'm going somewhere with this. Here it was water, here it was air molecules. But let's look at the sun. All right, the sun is sending its transverse light waves to the earth. All right, so the light waves are coming to the earth, and I want to know what substance is there that is being oscillated. What is the medium for the light waves that reach us from the sun? All right, the answer to this question has been mysterious for quite a while. And at first, someone came along and said that there's this stuff in space that we don't know much about, and it's called ether. But that theory has been debunked. No ether in outer space. So what is being oscillated? It turned out that a man named, wait a minute, just let me see what I said was going to be on today's notes. Where's today's notes? Oh yeah, light as a wave. Okay. I'm going to ask you to ponder, ponder this question, and I will answer it for you tomorrow. I'm kind of bleeding on tomorrow's notes. I want to know what substance what medium is being oscillated by a light wave. So we do have an answer to that. But before we go any further, let's talk about light as a wave. So we're not sure that there's anything out there that's any substance that's being oscillated. So is light a wave? Is it really a wave like we think of? So the answer came to us quite clearly from a man, and his name was James Maxwell. And this was about in the 1870s. He comes along and he did an experiment which proved to us that, oh, you know what, it wasn't Maxwell. Let me see. I'm sorry. I should know this. It's not Maxwell. Maxwell's against tomorrow. So put him on hold. He's going to answer this question for you. So sorry, James, to do you a misservice. Is light a wave? This other dude came along, and his last name was Young. Thomas Young. And he was like in the early 1800s. So Thomas Young came around and set up an experiment. I'd like to set up something similar, see if we can get it to work. So Thomas Young came along and he said, look at this. He imagined that the light waves, you know how the light waves are coming in toward you with their crests? And he said, let's say they're coming from far, so when they get to us, they're kind of parallel to one another, and they're coming toward an opening. If they were truly waves, and there was a barrier, like a wall of some kind with a small opening here, if they truly were waves, they would diffract. It's like if you send water waves through a small opening, they bend when they come through a small opening. It's called diffraction. Like that. And sure enough, when the waves, the light waves come in, when light hit this little opening, this slit, the waves did diffract like this, and then they headed out. And then he set up another another barrier. This time he's got two slits right here, an opening here and an opening here. And he thought, well, you can't really, because it's light and we can't really see it, if it was a wave it would diffract. So how do we know if it's diffracting or not? Well, then he let these diffracted waves hit these two slits. And if it was truly a wave, it would diffract again through both of the slits. So we would have some light coming through one and some coming through the other. Now, if light is truly a wave and it's truly diffracting, if we set up a screen over here, so this is our screen, what we would see would convince us, or not, if it was a wave. Because when this diffraction happens, some of the waves are interfering with other waves. And when wave interference, this phenomenon called wave interference, happens, it's when two waves overlap. So interference, when two waves overlap. Alright, so something interesting happens, like right here, when this wave overlaps this one, and right here, because I said I identified these lines as crests. So here we have the crest from one slit meeting the crest from another. So when two crests meet, they make a doubly high crest. So, and then what happens in here, let's say right there, I'll put a little X. Can you see there's an X there? There's a little X there because we had the trough of one. That's not exactly clear. I want to find a spot where the trough of one wave hits the trough of another. Let me put in these lines again. So here was a crest meeting a crest meeting a crest, and a crest meeting a crest. But sometimes the crest from one wave hits the trough from another wave. What would happen then? So I think that might happen like right here. So we have remember if these are crests, in between where there's nothing, right in the middle would be a trough. So here I have a trough meeting a crest. Well, if that happens, the wave should cancel out altogether. So if light is a wave, it diffracts again, creates this pattern where we have crests upon crests would make a very bright spot, and trough meeting a crest would make no light at all because it would cancel one another. So over here on the screen, if light is a wave and this diffraction is happening and this interference is happening, we should see a pattern on our screen of dark, light, dark and 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 light. And where we have the light is where so these would be little wider bands than that. We should have this banding effect. Because where we have a trough meeting a crest, we would have a dark spot with no light. And where we have a crest meeting a crest, as these move forward and hit the screen, we should see this banding. And guess what happens when we set this up? We do see this. So thank you, Mr. Thomas Young, for your brilliant mind in the 1800s, helping us see that yes, light is a wave. Young's experiment showed us that light is a wave. All right. So I think I'll leave that for now, and we will talk about what is the substance that light actually oscillates tomorrow, and that will be James Maxwell's answer to this question. All right. If you have more time, you can read ahead. Though I'm covering, I think, in the middle of 369, page 369, you can read ahead and see what the answer is to that question. All right, that's it for now. Have a good rest of your day. I miss you somewhat. Over and out. Carry on, class. Carry on.